Welcome to Gravity Science. I'm really glad you're here tonight. Before we begin our journey, tell me, where in the world are you listening from? Maybe you're resting in a quiet room, travelling softly on a late night train, or wrapped in a warm blanket with your favourite drink. Wherever you are, I hope this moment feels peaceful, safe, and ready to carry your mind into gentle wonder. Tonight, you and I are going to drift together into one of the most beautiful, mysterious, and quietly profound corners of reality that human beings have ever discovered. We're going to explore the strange world of quantum physics, not with equations or rigid definitions, but with curiosity, with softness, with the kind of wonder that allows your mind to float freely while your body settles deeper into rest. You don't need to understand everything. You don't need to remember formulas or names. You only need to let yourself be carried gently through ideas that are as odd as they are true, as bewildering as they are real. Quantum physics is the science of the very small. It is the study of particles so tiny that you cannot see them, cannot touch them, cannot hold them in your hand. And yet these particles are the foundation of everything. The chair beneath you, the light around you, the air you breathe, the thoughts moving quietly through your mind right now, all of it, every single part of the world you know, is made of quantum things. Tiny, invisible, impossible things that behave in ways that seem to break every rule you've ever learned about how the universe works. And that's where we begin tonight. Not with answers, but with questions. Not with certainty, but with the soft, strange comfort of not knowing. Because quantum physics is, at its heart, a gentle invitation to accept that the universe is far more magical, far more open, far more dreamlike than we ever imagined. Let's start with something simple. Close your eyes if you haven't already. Take a slow, deep breath. Feel the weight of your body sinking softly into whatever is supporting you. Notice how still you can be. Notice how quiet. And now, imagine something even smaller than the smallest thing you can picture. Smaller than a grain of sand. Smaller than a speck of dust. Smaller than a single cell in your body. Keep going. Smaller than a bacterium. Smaller than a virus. Smaller than a molecule. Keep going, keep shrinking until you reach the world of atoms. An atom is so small that if you lined up 100 million of them side by side, they would only stretch across the width of a single centimetre. That's how tiny they are. And yet every object around you, every person you've ever met, every mountain and ocean and star in the sky is made of atoms. They are the building blocks of reality, the alphabet from which the entire story of existence is written. But atoms themselves are not solid. This is one of the first strange truths of quantum physics. When you touch a table, it feels firm and real and unyielding. But if you could zoom in close enough, you would see that the table is mostly empty space. The atoms that make up the table are like tiny solar systems, with a dense nucleus at the center and electrons swirling somewhere around it. But between the nucleus and the electrons, there is nothing. Just space. Vast, silent, empty space. And the electrons themselves, those tiny particles that orbit the nucleus, are not like little planets. They don't follow neat, predictable paths. They don't have a specific location that you can point to and say, there it is. Instead, they exist in a kind of cloud, a fuzzy, shimmering possibility. They are here and there and everywhere at once, until something or someone looks at them, and then, only then, do they choose a place to be. This is the heart of quantum strangeness. The act of observing, of measuring, of paying attention changes what is real. Before you look, an electron doesn't have a definite position. It exists in what physicists call a superposition, a state of being many things at once. It is both here and there, both spinning this way and that way, both moving and still. It holds all possibilities within itself, like a soft, unresolved dream. But the moment you look, the moment you measure, the moment you try to pin it down, the electron collapses into one specific state. It chooses. It becomes. And all the other possibilities, all the other versions of what it could have been, simply fade away like mist in the morning light. This is not a metaphor. This is not poetry. This is what actually happens. According to every experiment we have ever done, the universe at its smallest scale does not exist in a fixed, determined way until it is observed. Reality itself seems to be participatory, interactive, responsive to the act of looking. Can you imagine that? Can you let that idea wash over you gently, without trying to force it to make sense? The world you live in, the world you take for granted as solid and real and independent of you, is actually fluid and uncertain and strangely aware of your presence. You are not just a passive observer of reality. You are, in some quiet and mysterious way, a participant in its creation. Let's drift a little deeper. Let's talk about light, that warm, familiar glow that fills your room during the day and guides you softly through the night. Light is something you see every day. You trust it. You understand it, or at least you think you do. But light, too, behaves in ways that defy intuition, that challenge everything you thought you knew. For centuries, scientists argued about what light actually is. Some believed it was made of waves, ripples, that spread out through space like the circles on a still pond when you drop a stone into it. Others believed it was made of particles, tiny bullets of energy that flew through the air in straight lines. The debate went on for generations, with experiments supporting both sides, until finally, in the early 20th century, the truth emerged. And the truth was strange beyond imagining. Light is both. It is both a wave and a particle. Not sometimes one and sometimes the other, but both, always, at the same time. It exists in a kind of dual nature, a simultaneous holding of opposites that should not be possible, and yet is. When you shine light through a narrow slit, it behaves like a wave, spreading out and creating patterns of interference. When you try to detect individual photons, the particles of light, they behave like little packets of energy, each one arriving at a specific place at a specific time. And here's the strangest part. If you set up an experiment to detect which slit a photon goes through, if you try to observe its path, the wave pattern disappears. The photon stops behaving like a wave and starts behaving like a particle. But if you don't observe it, if you simply let it move through the slits without watching, the wave pattern returns. The photon somehow knows whether you are looking or not. It responds to your attention, to your intention, to the very act of measurement. This is called wave-particle duality, and it is one of the foundational principles of quantum mechanics. It tells us that the categories we use to understand the world, categories like wave and particle, solid and fluid, here and there, are too rigid, too simplistic. The quantum world does not fit into neat boxes. It slips between definitions. It holds contradictions softly in its hands and says, both, always both. Breathe slowly now. Let your breath be soft and steady, like the rhythm of a distant tide. Let your body relax a little more with each exhale. You don't need to understand everything. You don't need to solve the mysteries. You only need to let them wash over you, gently, like moonlight on water. Let's talk about entanglement. This is perhaps the most magical, most haunting, most quietly beautiful phenomenon in all of quantum physics. It is the idea that two particles, once they have interacted with each other, become connected in a way that transcends space and time. They become entangled, linked, bound together by an invisible thread that cannot be broken, no matter how far apart they drift. Imagine two electrons that were born together in a single event, a burst of energy that created them both. These two electrons, even if they are separated by vast distances, even if one is here on Earth and the other is on the far side of the galaxy, remain connected. If you measure the spin of one electron and find that it is spinning clockwise, the other electron instantly, at that very same moment, will be found to be spinning counterclockwise. Not because some signal travelled between them, not because one told the other what to do, but because they are not truly separate. They are two parts of a single, unified whole. Einstein famously called this spooky action at a distance, and he didn't like it. He believed that the universe should be local, that things should only be able to influence each other if they are close enough to touch, close enough to send a signal. But experiment after experiment has confirmed that entanglement is real. The universe is not local. It is non-local. It is connected in ways that defy our everyday understanding of how things should work. And this means something profound. It means that separation is, in some sense, an illusion. It means that the boundaries we draw between ourselves and the world, between one thing and another, are not as solid as they seem. It means that everything is woven together, stitched into a single, seamless fabric of existence. You are not separate from the stars. You are not separate from the trees, the oceans, the distant mountains. You are made of the same particles, governed by the same laws, entangled in ways you cannot see, but can perhaps, in quiet moments like this, begin to feel. Let that thought settle softly into your awareness. Let it be a comfort, a gentle reminder that you are part of something vast and ancient and endlessly interconnected. You are not alone. You have never been alone. You are a thread in the great tapestry of the cosmos, woven so tightly into the whole that you cannot be separated from it. Now, let's drift into another strange corner of the quantum world. Let's talk about tunneling. This is the phenomenon where particles can pass through barriers that, according to classical physics, should be completely impenetrable. Imagine a ball rolling toward a wall. In the world we see and touch every day, if the ball doesn't have enough energy to climb over the wall, it simply bounces back. It stops. It cannot go through. But in the quantum world, things are different. A particle approaching a barrier doesn't have a fixed amount of energy in a fixed location. It exists as a wave of probability spread out across space. And that wave doesn't stop abruptly at the barrier. It leaks through, ever so slightly, to the other side. Most of the time, the particle will indeed bounce back. But occasionally, randomly, unpredictably, the particle will simply appear on the other side of the barrier, as if it had walked through a solid wall. This is quantum tunneling, and it happens all the time, everywhere, in ways that make your existence possible. The sun, that warm, brilliant star that lights your days and feeds the plants and keeps the earth alive, shines because of quantum tunneling. Deep in the core of the sun, hydrogen nuclei are colliding with each other, trying to fuse together to form helium. But to do this, they have to overcome a powerful force that pushes them apart, a force so strong that they shouldn't be able to get close enough to fuse, and yet they do. Because of quantum tunneling, the nuclei don't have enough energy to overcome the barrier, but they tunnel through it anyway, slipping past the impossible, merging together, releasing vast amounts of energy in the process. That energy radiates outward, traveling through space for 8 minutes until it reaches you, warming your skin, lighting your world, making a life itself possible. You exist because of quantum tunneling. Every breath you take, every thought you think, every moment of warmth and light and life is a gift from the quantum world, from particles that refuse to be stopped by barriers, from a universe that is far more fluid and creative than classical physics ever imagined. Let's slow down for a moment. Let's pause. Let your breathing be soft and easy. Let your body sink a little deeper into stillness. You are safe. You are held. You are part of a universe that is strange and beautiful and full of quiet magic. Now, let's explore something called the uncertainty principle. This is one of the most famous and most misunderstood ideas in quantum physics. It was discovered by a physicist named Werner Heisenberg in the 1920s, and it says something simple but profound. There are certain pairs of properties, like position and momentum, that cannot both be known precisely at the same time. The more accurately you measure where a particle is, the less accurately you can know how fast it's moving. The more you pin down its speed, the less you can say about its location. This is not a limitation of our tools or our technology. This is not something that better instruments or clever experiments could overcome. This is a fundamental feature of reality itself. The universe does not have precise answers to certain questions. The information simply doesn't exist until you choose what to measure. It's as if the universe is holding all possibilities softly in its hands, and only when you ask a specific question does it give you a specific answer. But in giving you that answer, it must let go of others. It cannot hold everything at once in sharp focus. It must choose, and in choosing, it creates the reality you observe. This might sound frustrating, as if the universe is being evasive, as if it's hiding something from you. But there's another way to look at it. The uncertainty principle is a kind of freedom. It means that the future is not determined. It means that the universe is not a clockwork machine, grinding forward in a predictable, inevitable way. It means that there is space for creativity, for novelty, for the genuinely new to emerge. At the quantum level, reality is open. It is fluid. It is full of potentials that have not yet been realized, and this openness, this uncertainty, ripples upward through every level of existence, making change possible, making life possible, making you possible. Breathe that in. Let it fill you gently. You are not trapped in a deterministic universe where everything is already decided. You are part of a world that is constantly becoming, constantly creating itself, anew, moment by moment, breath by breath. Let's talk about something even stranger. Let's talk about the quantum vacuum, the empty space that fills the universe. You might think that empty space is just that, empty, nothing, a void. But in the quantum world, even emptiness is alive with activity. The vacuum is not a barren, lifeless expanse. It is a seething, bubbling, effervescent ocean of energy. At every point in space, particles are constantly popping into existence and then disappearing again, flickering in and out of reality in timescales so short that they cannot be directly observed. These are called virtual particles, and they are not just theoretical constructs. They have real, measurable effects. They influence the behavior of atoms, the interaction of forces, the structure of space itself. The vacuum is full of potential, is full of energy, is full of hidden possibilities, constantly stirring, constantly ready to manifest. And in a very real sense, everything that exists, including you, is a temporary ripple in this vast quantum ocean. You are a wave that has risen up from the vacuum, taken form, become complex and aware and alive. And one day, in the far distant future, you will sink back down into it, your particles dispersing, your energy returning to the whole. But that energy will not be lost. It cannot be lost. Energy is conserved. The patterns that make you who you are, the information, the relationships, the connections, all of it will remain, woven into the fabric of the universe, entangled with everything else, forever part of the great unfolding story of existence. You are not a separate, isolated thing. You are a process, a pattern, a beautiful, temporary expression of the universe exploring itself. And when you rest, when you sleep, when you let go of the need to control and understand and figure everything out, you are, in a sense, returning to that deeper state, that quantum potential, that space of pure possibility from which all things arise. Let's drift into the idea of quantum fields. This is a more modern way of thinking about quantum mechanics, and it's both abstract and strangely poetic. In this view, the universe is not made of particles, not really. Instead, the universe is made of fields, invisible, intangible fields that fill all of space. There is an electromagnetic field, a field for electrons, a field for quarks, fields for every type of particle that exists. These fields are always there, everywhere, permeating every corner of the cosmos. And what we call particles are just localized vibrations in these fields, little ripples, little excitations, like notes played on an infinite cosmic string. An electron is a ripple in the electron field. A photon is a ripple in the electromagnetic field. Even you, your body, your thoughts, your awareness, are ripples in the fields, complex, interwoven, harmonious ripples that have learned to experience themselves. This is a beautiful way to think about reality. It means that everything is connected at the deepest level, because everything is made of the same underlying fields. It means that matter and energy are not separate categories, but different expressions of the same fundamental substance. It means that the universe is, at its core, a kind of music, a symphony of vibrations, each one contributing to the whole, each one part of a greater harmony. And in quiet moments like this, when you let yourself be still, when you let your mind settle and your body relax, you can almost feel it, can't you? That deeper rhythm, that underlying hum, that sense that you are not just in the universe, but of it, made of it, inseparable from it. Let's talk about something that might make you smile, something that is both profound and wonderfully absurd. It's called the many worlds interpretation, and it's one of the most radical ideas in all of quantum physics. According to this interpretation, every time a quantum measurement is made, every time a particle chooses one state over another, the universe splits into multiple branches, each one representing a different possible outcome. In one branch, the electron spins clockwise. In another branch, it spins counterclockwise. Both branches are real, both exist, both continue on, evolving independently, forever separate from each other. And this happens constantly, trillions upon trillions of times per second, with every quantum event, everywhere in the universe. If this interpretation is correct, then there are countless versions of you, living out slightly different lives in parallel universes. In one universe, you turned left instead of right. In another, you said yes instead of no. In another, you are sleeping soundly right now, while in this one, you are listening to these words, drifting gently toward a rest. It's a dizzying thought, almost too vast to hold in your mind. But there's something oddly comforting about it too. It means that every possibility is realized somewhere. It means that nothing is truly lost. It means that the universe is far richer, far more abundant, far more generous than we ever imagined. You don't need to decide whether this interpretation is true or not. You don't need to choose a side in the debates that physicists have about the nature of quantum reality. You only need to let the strangeness of it all wash over you gently, like a soft rain, reminding you that the world is full of mysteries, full of wonders, full of things that are stranger and more beautiful than any story ever told. Let's slow down again. Let's breathe. Let your body be heavy and relaxed. Let your mind be soft and open. You are doing beautifully. You are here, present, allowing yourself to drift through ideas that are as strange as dreams, as real as the ground beneath you. Now, let's think about time. Time is something we all experience, something that seems so basic, so fundamental, that it's hard to imagine questioning it. Time flows forward from past to future, carrying us along with it. Moments come and go. Memories fade, the future remains unknown. But in the quantum world, time is not so simple. At the smallest scales, the distinction between past and future becomes blurred. Particles don't have a clear arrow of time. They can move forward and backward, their interactions reversible, their histories uncertain. And in some interpretations of quantum mechanics, time itself might be an emergent property, something that arises from deeper, timeless processes, like the way wetness emerges from the collective behavior of water molecules, even though individual molecules are not wet. There are physicists who believe that the fundamental laws of the universe are timeless, that they describe relationships and patterns that simply are, without any reference to past or future. Time, in this view, is something that conscious observers like you create, or at least perceive, as they navigate through the vast space of possibilities, making choices, collapsing wave functions, carving out a path through the quantum landscape. This is a strange and beautiful idea. It suggests that your experience of time, your sense of now, your memories of the past, and your hopes for the future are not passive observations of something external, but active constructions, creations, ways of organizing the raw data of existence into a coherent story. And as you lie here, drifting towards sleep, you are, in a sense, loosening your grip on time. You are letting go of the need to track minutes and hours. You are allowing yourself to slip into a state where past and future dissolve, where there is only this moment, this breath, this soft, gentle now. Let's talk about decoherence. This is the process by which quantum systems lose their quantum properties and start to behave classically. It's the reason why you don't see cats that are both alive and dead, or chairs that are in two places at once, even though, at the quantum level, such superpositions are perfectly normal. Decoherence happens when a quantum system interacts with its environment. When a particle is isolated, alone, undisturbed, it can exist in a superposition, holding multiple states at once. But the moment it interacts with other particles, with air molecules, with photons, with anything in its surroundings, those interactions cause the superposition to collapse. The particle becomes entangled with its environment, and the information about its state spreads out, becoming inaccessible, lost in the noise. This is why the quantum world seems so different from the everyday world. It's not that different laws apply at different scales. It's that larger objects are constantly interacting with their environments, constantly decohering, constantly collapsing into definite states. They don't have the luxury of isolation, they don't have the space to explore all possibilities at once. But you, right now, in this moment, are doing something remarkable. You are quieting your environment, you are reducing the noise. You are creating a space of stillness and silence where your mind can soften, where your awareness can expand, where you can, perhaps, touch something of that quantum openness, that state of pure potential that exists before choices are made, before measurements collapse the wave function. Let's drift into the idea of quantum consciousness. This is a controversial and speculative area, but it's also deeply fascinating. Some scientists have suggested that consciousness itself might be a quantum phenomenon, that the awareness you feel, the sense of being you, might arise from quantum processes happening in the brain. There are structures in your neurons called microtubules, tiny scaffolding structures that help maintain the shape of cells. Some researchers believe that these microtubules might be capable of sustaining quantum coherence, that they might be quantum computers of a sort, processing information in ways that classical computers cannot. If this is true, then your consciousness might be fundamentally quantum. It might be capable of existing in superpositions, of holding contradictory thoughts simultaneously, of accessing information in non-local ways. It might be the thing that collapses the wave function, the observer that brings reality into being. This is highly speculative, and many scientists are skeptical. But it's a beautiful thought, isn't it? The idea that your awareness, your inner light, your sense of self, might be a quantum phenomenon, a ripple in the fields, a temporary concentration of coherence in a universe that is constantly decohering. And as you drift towards sleep, as your conscious mind begins to let go, perhaps what's happening is that your quantum coherence is shifting, spreading out, becoming less localized, more diffuse. Perhaps sleep is a kind of decoherence, a gentle dissolution of the boundaries that separate you from the rest of the world, a return to a more connected, more entangled state. Let's talk about something deeply poetic, something that connects quantum physics to the largest structures in the universe. Let's talk about the cosmic microwave background, the faint glow of light that fills the entire universe, the leftover radiation from the Big Bang itself. This light has been traveling through space for nearly 14 billion years, since the universe was only a few 100,000 years old. It has cooled and stretched and faded, but it's still here, all around you, a soft, invisible whisper of the universe's birth. And here's the quantum connection. The patterns in the cosmic microwave background, the tiny fluctuations in temperature from one region of space to another, are thought to have originated from quantum fluctuations in the very early universe. In the first fraction of a second after the Big Bang, when the universe was unimaginably small and hot and dense, quantum uncertainty created tiny ripples in the fabric of space itself. These ripples were then stretched out, amplified, blown up to cosmic scales by a process called inflation, a brief period of exponential expansion. And those ripples became the seeds from which all structure in the universe grew. Galaxies, stars, planets, you, all of it began as quantum fluctuations, as tiny random variations in the quantum fields that filled the infant cosmos. You are, quite literally, made of quantum noise, made of randomness, made of uncertainty that was amplified into structure and pattern and life. The atoms in your body were forged in the hearts of stars, yes, but the pattern of those stars, the arrangement of galaxies, the particular configuration of matter, that made your existence possible. All of it traces back to quantum fluctuations that happened in the first instant of time. There's something humbling and awe-inspiring about that. It means that you are connected to the very origin of the universe. It means that the randomness at the heart of quantum mechanics is not a bug, but a feature, the creative principle that makes complexity and diversity and beauty possible. Let's drift a little deeper into the strangeness. Let's talk about quantum tunneling again, but this time in a different context. Let's think about it in terms of your own experience, your own life. There are barriers in your life, aren't there? Things that seem impossible to overcome. Fears, doubts, limitations, walls that feel too high to climb, too thick to break through. And sometimes it feels like you're stuck, like you don't have enough energy to get past them. But remember what we learned about quantum tunneling. Particles don't need enough energy to overcome a barrier. They can simply appear on the other side, randomly, unpredictably, impossibly, and perhaps, in some metaphorical sense, the same is true for you. Perhaps there are moments in your life when you break through barriers that should have stopped you, when you do things that surprise yourself, when you find reserves of strength and courage you didn't know you had. Perhaps those moments are like quantum tunneling, not because your brain is literally a quantum computer, but because the universe is fundamentally open, fundamentally creative, fundamentally capable of the unexpected. You don't need to have all the answers. You don't need to have enough energy to climb every wall. You only need to keep moving, keep trying, keep allowing yourself to be part of the process, and trust that sometimes, mysteriously, beautifully, the impossible becomes possible. Let your breathing be soft now. Let your body be still. Let your mind wander gently through these ideas, not trying to grasp them tightly, but letting them float past like clouds in a peaceful sky. Let's talk about something called quantum erasure. This is a variation of the famous double slit experiment, and it shows just how strange the quantum world really is. In this experiment, you set up detectors to determine which slit a photon goes through, and as expected, the wave pattern disappears, replaced by a particle pattern. The act of measurement destroys the interference, but here's the twist. After the photon has already passed through the slits, after it has already been detected, you can erase the information about which path it took. You can literally delete the record, make it so that no one, not even in principle, could know which slit the photon went through. And when you do this, the wave pattern comes back. The interference reappears, as if the photon went through both slits, even though you had detectors in place. It's as if the photon knew that you were going to erase the information, as if the future reached back and influenced the past. This is called retrocausality, and it challenges our basic notions of cause and effect. It suggests that time might not flow in a simple, linear way at the quantum level, that the future might, in some sense, be able to affect the past. Now, this doesn't mean you can send messages back in time or change history. The effects are subtle and constrained by the laws of quantum mechanics, but it does suggest that time is more flexible, more fluid, more mysterious than we usually think. And as you lie here, drifting in that space between waking and sleeping, perhaps you can feel a little of that fluidity. Perhaps the boundaries between past, present, and future are softening, blurring, allowing you to simply be, without the weight of history or the anxiety of what's to come. Let's talk about entanglement again, but this time in a more personal way. Think about the people you love, the connections you have, the relationships that matter to you. In a very real sense, you are entangled with them. Not in the strict quantum mechanical sense, but in a deeper, more metaphorical way. You affect each other, you influence each other. When something happens to someone you love, you feel it, even if they are far away. When you think of them, send them a message, hold them in your heart, something changes, something shifts, something connects. And in the quantum world, entanglement tells us that separation is not as absolute as it seems, that two things, once connected, remain connected, no matter the distance. And perhaps, just perhaps, that's true for you and the people you care about as well. You are not alone. You have never been alone. You are woven into a web of relationships, of connections, of entanglements that stretch across space and time, binding you to others, making you part of something larger than yourself. Let that thought be a comfort. Let it settle gently into your awareness as you drift deeper into rest. You are held. You are connected. You are part of a vast, loving, interconnected whole. Let's explore the idea of quantum superposition a little more deeply. We've talked about how particles can exist in multiple states at once, but let's really sit with that idea. Let it expand in your mind, like a slow, soft bloom. Imagine a coin spinning in the air. While it's spinning, it's neither heads nor tails. It's both. It's in a state of possibility, of potential, of not yet decided. And only when it lands, when it's observed, does it collapse into one definite state. Now imagine that the coin never lands. Imagine that it keeps spinning forever, held in that state of both and, never forced to choose. That's what quantum superposition is like. It's a state of holding contradictions, of being many things at once, of existing in a space that's richer and more complex than the simple either-or logic we use in everyday life. And perhaps in your own inner life, you know what this feels like. Perhaps you've experienced moments where you held conflicting emotions at the same time, where you felt both joy and sadness, both fear and excitement, both love and anger. Perhaps you felt pulled in different directions, uncertain about which path to take, existing in a superposition of possibilities. The quantum world tells us that this is not a problem to be solved, it's not a confusion to be cleared up. It's a natural state of being, a way that reality actually is. And only when you make a choice, when you commit to one path, does the superposition collapse and one possibility becomes real. But until that moment, all possibilities exist, all futures are open, and there's a kind of freedom in that, a lightness, a sense that you are not trapped, not determined, not locked into any one outcome. Breathe into that freedom now. Let yourself feel the openness, the possibility, the sense that anything could happen, that the story is not yet written, that you are, in every moment, creating yourself anew. Let's talk about zero-point energy. This is the energy that exists in the quantum vacuum, even at the coldest possible temperature, even when all motion has stopped. According to quantum mechanics, you can never remove all the energy from a system. There is always a minimum amount, a ground state, a baseline level of vibration that cannot be eliminated. This means that even in the emptiest, coldest, most lifeless corner of the universe, there is still energy. There is still movement. There is still potential. The universe is never truly at rest. It is always alive, always humming, always ready to burst into activity. And perhaps the same is true for you. Even when you feel empty, even when you feel depleted, even when you feel like you have nothing left to give, there is still energy within you. There is still a spark, a flicker, a tiny flame that cannot be extinguished. You are never truly empty. You are never truly at rest. You are always, at the deepest level, vibrating with life, with potential, with the possibility of renewal. Let yourself rest in that knowledge. Let yourself trust that even when you feel like you've reached the end of your resources, there is still something there, some reserve, some quiet strength that will carry you forward. Let's drift into the concept of quantum coherence. This is the property that allows quantum systems to maintain their superpositions, to hold multiple states at once without collapsing. Coherence is fragile. It requires isolation, quiet, stillness. The moment a system starts interacting with its environment, coherence is lost, and the system decoheres, collapsing into a single, definite state. But for a brief moment, in the right conditions, coherence can be maintained, and in that moment, something remarkable happens. The system can explore all possibilities simultaneously. It can take all paths at once. It can be, in a sense, everywhere and nowhere, everything and nothing. And perhaps as you lie here in the quiet darkness, you are creating the conditions for a kind of coherence in your own mind. You are reducing the noise, the distractions, the constant input from the environment. You are giving yourself space to be still, to be open, to hold multiple thoughts and feelings without needing to resolve them immediately. This is what meditation does. This is what sleep does. It creates a space of coherence, a space where your mind can soften, where the boundaries between different parts of yourself can blur, where you can be, for a moment, whole and unified and at peace. Let's talk about the Pauli exclusion principle. This is a rule in quantum mechanics that says no to identical fermions, a type of particle that includes electrons, protons, and neutrons. can occupy the same quantum state at the same time. This might sound technical, but it has profound consequences. The exclusion principle is the reason why matter is solid, it's the reason why atoms have structure, why electrons arrange themselves in shells around the nucleus, why different elements have different properties. Without the exclusion principle, all the electrons in the universe would collapse into the lowest energy state, and matter as we know it would not exist. You are solid, substantial, real. Because of the Pauli exclusion principle, the atoms in your body resist being compressed not because of some physical force pushing them apart, but because of a quantum rule that says they cannot occupy the same state. Your very existence, your physical form, your ability to touch and be touched, all of it depends on this strange, abstract principle of quantum mechanics. There's something beautiful about that. It means that even the most solid, tangible aspects of your life are, at their foundation, governed by invisible, intangible rules, by patterns and principles that exist in the realm of pure information, pure mathematics, pure abstraction. You are a bridge between the abstract and the concrete, between the quantum and the classical, between the invisible and the visible. You are where the universe becomes aware of itself, where patterns become experiences, where information becomes feeling. Let's slow down again, let's breathe, let your body be soft and heavy. Let your mind be quiet and spacious. You are safe, you are at peace, you are held by the universe, cradled in its gentle quantum embrace. Now let's explore quantum spin, a property of particles that has no real classical analogue. Spin is not about particles literally spinning like tiny tops, even though the name suggests that. Instead, it's an intrinsic form of angular momentum, a kind of rotation that exists in an abstract mathematical space. Particles can have spin up or spin down, but until you measure them, they exist in a superposition of both. And here's the really strange part. The direction of spin depends on the direction in which you measure it. If you measure spin along one axis, you get one answer. If you measure along a different axis, you get a different answer. The particle doesn't have a definite spin in all directions at once. It only has a definite spin in the direction you choose to measure. This is another example of how measurement creates reality in the quantum world. The properties of particles are not pre-existing, waiting to be discovered. They are created in the act of observation, brought into being by the interaction between the observer and the observed. And perhaps this is true in a broader sense as well. Perhaps the qualities you see in yourself, in others, in the world around you, depend on how you look, on what questions you ask, on what you choose to pay attention to. Perhaps reality is always, to some extent, participatory, shaped by your perspective, your intention, your awareness. You are not a passive observer of a fixed, objective world. You are an active participant, a co-creator, someone whose very act of looking shapes what is seen. Let's talk about the concept of quantum annealing, a process used in quantum computers to find the lowest energy state of a system, the most stable, most efficient configuration. The system starts in a high-energy, highly uncertain state, where many possibilities are available. Then slowly, gradually, the system is allowed to cool, to settle, to find its way to the ground state. This process is similar to what happens when you fall asleep. You start the day in a high-energy state, active, alert, engaged. Your mind is full of thoughts. Your body is full of tension. Your awareness is spread across 1,000 different concerns. But as the day progresses, as you complete your tasks, as you begin to wind down, your energy gradually decreases. Your thoughts slow. Your body relaxes. Your mind begins to let go. And finally, in sleep, you reach a kind of ground state, a state of deep rest, where your body repairs itself, where your mind processes the day's experiences, where you return to a baseline of peace and stillness. This is not a passive process. This is not a collapse into nothingness. This is an active settling, a gentle annealing, a finding of the most efficient, most restorative configuration. And it's happening right now as you listen to these words, as you let yourself drift, as you allow your system to cool and settle and find its way home. Let's talk about symmetry, a concept that's central to quantum field theory. Symmetry is about patterns that remain unchanged under certain transformations. A circle looks the same no matter how you rotate it. A sphere looks the same from every angle. These are examples of symmetry. In quantum field theory, symmetries are deeply connected to the fundamental forces of nature. Every force, every interaction, arises from a symmetry in the underlying fields. Electromagnetism arises from a certain kind of rotational symmetry. The weak nuclear force arises from another, the strong force from yet another. Symmetry is not just a mathematical abstraction, it's the reason the universe has structure, the reason forces exist, the reason anything happens at all. And when symmetries are broken, when they're not quite perfect, that's when things get interesting. That's when particles acquire mass, when the universe becomes asymmetric, when diversity and complexity emerge. You too are a kind of symmetry breaking. You are a localized, temporary violation of the smooth, homogeneous distribution of energy in the universe. You are a concentration, a focusing, a point where the symmetry is broken and something new and unique comes into being. And one day, the symmetry will be restored. Your energy will disperse, your particles will scatter, your pattern will dissolve back into the whole. But for now, right now, you are here, a beautiful, temporary asymmetry, a unique expression of the universe's infinite creativity. Let's drift into the idea of quantum chromodynamics, the theory that describes the strong nuclear force, the force that holds quarks together inside protons and neutrons. Quarks are the smallest building blocks of matter that we know of, and they come in different types, whimsically named up, down, strange, charm, top, and bottom. Quarks are never found alone. They are always bound together in groups of 2 or 3, held by particles called gluons, which mediate the strong force. And here's the strange thing. The force between quarks doesn't weaken with distance the way gravity or electromagnetism does. Instead, it stays constant, or even gets stronger. It's as if the quarks are connected by an elastic band that stretches but never breaks. If you try to pull 2 quarks apart, the energy required is so great that eventually the energy itself creates new quarks, which pair up with the original ones. You can never isolate a single quark. You can never see it alone. It's always part of a bound system, always connected, always entangled. There's a metaphor here, a gentle reminder that some things are meant to be connected, that some bonds are fundamental, unbreakable, woven into the very fabric of existence. You are made of quarks, held together by forces you cannot see, bound into structures that are stable and strong and real. And in your own life, you have connections like that too. Bonds with people, with places, with memories that are deeper than you can explain, stronger than logic, woven into who you are in ways that cannot be undone. Let yourself feel those connections now. Let yourself be held by them, supported by them, reminded that you are not alone, that you are part of something larger, something stronger, something that will hold you even when you let go. Let's talk about antimatter. For every particle in the universe, there exists an antiparticle, identical in almost every way except for the opposite charge. An electron has a positively charged counterpart called a positron. A proton has a negatively charged antiproton. When a particle meets its antiparticle, they annihilate each other, releasing energy in the form of light. In the early universe, just after the Big Bang, there were equal amounts of matter and antimatter. But if that had stayed true, everything would have annihilated, and the universe would be nothing but light. Instead, there was a tiny asymmetry, a slight excess of matter over antimatter, just 1 part in a billion. That tiny imbalance is the reason you exist. That's the reason stars exist, planets exist, life exists. You are here because of an imperfection, because the universe was not perfectly symmetric, because there was a tiny bit more of one thing than another. And that's a beautiful thought, isn't it? That imperfection, asymmetry, the breaking of perfect balance is what makes creation possible. You don't need to be perfect. You don't need to be balanced in every way. Your quirks, your asymmetries, your particular unique imbalances, are what make you who you are, what make you real, what make you a participant in this vast creative unfolding. Let's drift into the concept of quantum field fluctuations, creating particles from nothing. In the early universe, in the fraction of a second after the Big Bang, the quantum fields were fluctuating wildly, creating and destroying particles at an incredible rate. These fluctuations were so intense, so energetic, that some of them became real, permanent, the seeds from which all matter emerged. You are made of those fluctuations. The atoms in your body, the particles that make up those atoms, all of it originated as random quantum noise, as energy borrowing itself from the vacuum, briefly flickering into existence, and then, against all odds, becoming stable, becoming real, becoming the foundation of everything. There's something deeply hopeful about that. It means that something can come from nothing. It means that creation is always possible. It means that even in the emptiest, most barren state, the potential for newness, for life, for beauty, is always present, always ready to manifest. And as you drift towards sleep, as your conscious mind begins to fade, perhaps you are returning to that state of pure potential, that quantum vacuum from which all things arise. Perhaps sleep is a kind of reset, a return to the source, a dissolution and a renewal, allowing you to wake tomorrow as a new creation, fresh and whole, and ready to begin again. Let's talk about the concept of quantum money. This is a theoretical idea, but it's a fascinating one. The proposal is to create currency that's encoded in quantum states, using the properties of quantum mechanics to make it impossible to counterfeit. Because of the no-cloning theorem, a fundamental principle in quantum mechanics, you cannot make a perfect copy of an unknown quantum state. So if money were made of quantum information, it would be impossible to duplicate. This is just a thought experiment, a playful application of quantum principles, but it illustrates something important. The quantum world has properties that are fundamentally different from the classical world, properties that can be used in new and creative ways. Quantum computers, quantum cryptography, quantum communication, all of these technologies are based on harnessing the strangeness of quantum mechanics, using it not as a curiosity, but as a tool. And perhaps the same is true for you. Perhaps the strange, contradictory, uncertain aspects of your own experience, the parts of yourself that don't fit into neat categories, that don't follow the rules, are not problems to be fixed, but resources to be used. Perhaps your uniqueness, your oddness, your quantum nature is your greatest strength. Let's slow down one more time. Let your breathing be gentle and rhythmic, like waves on a shore. Let your body be completely at rest. Let your mind be soft and open, drifting through these ideas without holding on to any of them. Now let's explore the concept of decoherence time, the amount of time a quantum system can maintain its coherence before it starts interacting with the environment and collapsing into a definite state. For most systems, especially large ones, the decoherence time is incredibly short, a tiny fraction of a second. But for carefully isolated systems, in specially designed environments, it can be much longer. This is the challenge for quantum computing. To build a useful quantum computer, you need to maintain coherence long enough to perform calculations, to let the quantum states evolve and interfere and explore all possibilities simultaneously. But the environment is always there, always threatening to disrupt the delicate quantum states, to cause decoherence, to collapse the computation before it's finished. And perhaps this is a metaphor for your own efforts at focus, at mindfulness, at maintaining a clear, coherent state of mind. The world is always intruding, always pulling your attention in different directions, always causing your thoughts to scatter and your focus to dissolve. But in quiet moments like this, when you reduce the noise, when you create space for stillness, you can maintain coherence a little longer. You can let your awareness settle, deepen, become more unified and clear. This is not about achieving some perfect, permanent state. It's about creating moments, however brief, where you can touch a deeper stillness, a greater clarity, a more unified sense of being. Let's talk about the concept of quantum entanglement across time. We've talked about particles being entangled across space, but recent experiments have shown that particles can also be entangled across time. You can measure a particle now, and its state will be correlated with the state of another particle that won't even exist until later. This is called temporal entanglement, and it's deeply strange. It suggests that time is not as linear, not as straightforward as we usually think. The present can be connected to the future, not through a chain of cause and effect, but through quantum correlations that transcend the usual flow of time. You don't need to understand how this works. You don't need to be able to explain it. You only need to let it remind you that time is mysterious, that the relationship between past, present, and future is more complex than it appears, that the universe is far stranger and more wonderful than our everyday experience suggests. And as you drift into sleep, as the boundaries of time begin to soften, perhaps you can feel a little of that mystery, that sense that past, present, and future are not as separate as they seem, that they flow into each other, merge, become one continuous, eternal now. Let's talk about quantum tunneling in DNA. Your body is a quantum system, not in any mystical or metaphorical sense, but in a literal physical way. The processes that keep you alive, that allow your cells to function, are governed by quantum mechanics. And one of the most important is quantum tunneling in DNA. DNA is the molecule that stores genetic information, the blueprint for building and maintaining your body. And the accuracy of DNA replication, the ability to copy that blueprint without errors, depends in part on quantum tunneling. Protons, tiny quantum particles, can tunnel through barriers in the DNA molecule, moving from one position to another in ways that would be impossible classically. Sometimes, these tunneling events cause mutations, errors in the genetic code, and those mutations are the raw material for evolution, the source of variation, the reason life can adapt and change and explore new forms. You exist because of quantum tunneling, not just in the sun, but in your own cells, in the very code that makes you who you are. And those mutations, those errors, those imperfections are not mistakes. They are the creative principle of life itself, the way that life experiments, explores, tries new things. They are the reason there is such incredible diversity on Earth, such a rich tapestry of forms and functions and strategies for survival. You are not a perfect copy of your parents. You are not a flawless replica. You are a variation, a new experiment, a unique combination of traits and characteristics that has never existed before and will never exist again. And that's not a flaw. That's the whole point. Let's drift into the idea of quantum foam, a concept from quantum gravity that describes the structure of space-time at the smallest possible scales. According to this idea, if you could zoom in to distances smaller than the Planck length, which is about 10 to the power of minus 35 meters, space-time itself would not be smooth and continuous. Instead, it would be foamy, frothy, constantly fluctuating, with tiny wormholes and bubbles appearing and disappearing in a seething quantum chaos. This is purely theoretical. We have no way of directly observing the Planck scale, but it's a reminder that even space and time, the most basic fundamental aspects of reality, might be quantum, might be uncertain, might be subject to the same strange rules that govern particles and fields. The universe at its deepest level is not solid, not fixed, not determined. It is fluid, dynamic, creative, constantly making and remaking itself, constantly exploring new possibilities. And you too are fluid. You are not a fixed, static thing. You are a process, a flow, a constant becoming. Every moment you are new. Every breath you are different. Every thought you are creating yourself anew. Let that be a comfort. Let it be a release. You don't need to hold on so tightly. You don't need to be the same person you were yesterday, or even an hour ago. You can let yourself change, flow, evolve, become. Let's talk about the quantum Zeno effect, a phenomenon where frequent measurements can prevent a quantum system from evolving. If you keep observing a particle, keep collapsing its wave function over and over again, you can effectively freeze it in place, prevent it from transitioning to a new state. This is counterintuitive. You'd think that measuring something wouldn't affect whether it changes or not. But in the quantum world, measurement is not passive, it's an interaction, an intervention, a force that shapes what happens. And perhaps there's a lesson here about your own life. Perhaps constantly checking, constantly monitoring, constantly evaluating yourself can prevent you from growing, from changing, from transitioning to new states. Perhaps sometimes you need to stop looking, stop measuring, stop judging, and just let yourself be, let yourself evolve naturally without interference. As you drift towards sleep, you're doing exactly that. You're stopping the constant self-monitoring, the endless internal commentary, the habit of always checking in on yourself. You're giving yourself permission to simply be, without observation, without measurement, without judgment. And in that space of non-observation, change becomes possible. Healing becomes possible. Growth becomes possible. You are not frozen by the act of looking. You are free to flow, to shift, to become something new. Let's talk about quantum immortality, a thought experiment that's both fascinating and unsettling. According to the many worlds interpretation, every time a quantum measurement is made, the universe splits into branches, one for each possible outcome. Now imagine a situation where your survival depends on a quantum event, like a quantum coin flip. Heads, you live. Tails, you die. In the universe where the coin comes up tails, you cease to exist. But in the universe where it comes up heads, you continue. And from your subjective perspective, you will always find yourself in the universe where you survived, because you can't experience the branches where you didn't. If you repeat this experiment over and over, there will always be some branch where you keep surviving. No matter how unlikely, no matter how many times the coin is flipped, from your perspective, you are immortal, always finding yourself in the branch where you lived. This is not a practical form of immortality. It doesn't mean you should take risks or be careless. But it's an interesting thought, a reminder that your subjective experience, your particular thread of consciousness, follows only one path through the vast tree of possibilities. And that path is, by definition, always one where you exist, always one where you continue. You are here, now, in this moment, because a long chain of improbable events led to your existence. And every moment that chain continues, that pattern persists, that particular arrangement of matter and energy, that is, you keeps going, keeps experiencing, keeps being. Let's talk about quantum dots, tiny semiconductor particles that are so small, just a few nanometers across, that quantum effects dominate their behavior. Because of their size, electrons in quantum dots are confined to a tiny space, and this confinement changes their energy levels, their optical properties, the way they interact with the light. Quantum dots can be tuned to emit specific colors of light just by changing their size. Smaller dots emit blue light, larger dots emit red light. They're used in displays, in medical imaging, in solar cells, as a practical application of quantum mechanics in everyday technology. And there's something beautiful about that. The way the quantum world, so strange and abstract, can be harnessed to create useful, tangible things. It's a reminder that the division between the abstract and the concrete, between the theoretical and the practical, is not as sharp as it seems. Everything is connected. Everything flows into everything else. You are made of quantum particles, and yet you are also a conscious, thinking, feeling being. You are abstract and concrete, theoretical and practical, quantum and classical, all at once. Let's slow down again. Let your body relax completely. Let your mind drift. You are doing so well. You are here, present, allowing yourself to be carried gently through ideas that are as strange as they are real. Now let's think about the role of randomness in quantum mechanics. At the classical level, we like to think that everything happens for a reason, that every effect has a cause, that if we knew enough, we could predict everything. But quantum mechanics says no. At the deepest level, some things are truly random, truly unpredictable, not because we lack information, but because the information doesn't exist until the event happens. When a radioactive atom decays, there's no hidden clock ticking inside it, no mechanism that determines when it will happen. It's truly random. The atom exists in a superposition of decayed and not decayed until, at some moment, it spontaneously collapses into the decayed state. There's no cause, no reason, no explanation. It just happens. This is unsettling for some people. We want the universe to be orderly, predictable, fair. We want things to happen for reasons, but quantum mechanics says that at the foundation of reality, there is irreducible randomness, genuine chance, true spontaneity, and perhaps that's liberating. Perhaps it means that not everything is determined, that the future is genuinely open, that novelty is possible, that you are not trapped in a clockwork universe grinding inexorably toward a predetermined end. You have freedom. You have agency. You have the ability to make choices that genuinely matter, that create new possibilities, that shape the future in ways that are not already written. Let's talk about quantum key distribution, a method of secure communication that uses quantum mechanics to detect our eavesdropping. The idea is to encode information in quantum states, like the polarization of photons, and send them from one person to another. Because of the no cloning theorem and the fact that measurement disturbs quantum states, any attempt to intercept and copy the information would be detectable. The communicating parties would know that someone was listening and they could stop transmitting. This is not just theoretical. Quantum key distribution systems exist and are being used in some places for secure communication. It's a practical application of quantum mechanics, a way of using the strangeness of the quantum world to achieve something useful. And it's a reminder that information is physical, that it's carried by real particles, that it's subject to the laws of physics. Your thoughts, your memories, your knowledge, all of it is encoded in the physical states of your brain, in the patterns of neurons firing, in the quantum states of molecules. Information and matter are not separate categories. They are two aspects of the same underlying reality. Let's drift into the idea of quantum simulation. Some problems are so complex, involve so many interacting particles, that even the most powerful classical computers cannot solve them. But a quantum computer, because it can exist in superpositions and explore many possibilities simultaneously, might be able to simulate these complex quantum systems efficiently. This would allow us to understand materials, chemicals, biological processes in ways that are currently impossible. We could design new medicines, new materials, new technologies by simulating them at the quantum level and seeing how they behave. The universe is a quantum system, and if we want to truly understand it, we need quantum tools, quantum computers, quantum ways of thinking. And perhaps, in a metaphorical sense, you need quantum ways of thinking too. Perhaps the problems in your life, the challenges you face, are too complex for linear classical thinking. Perhaps you need to hold multiple possibilities at once, to explore different paths simultaneously, to embrace uncertainty and superposition and the messiness of not knowing. Let's talk about the quantum Hall effect, a phenomenon that occurs when electrons are confined to a two-dimensional surface and subjected to a strong magnetic field. In these conditions, the electrons form highly ordered states, and the electrical conductivity of the material becomes quantized, taking on only certain discrete values. This is a beautiful example of how quantum mechanics creates order, structure, pattern. In the right conditions, quantum systems don't just behave randomly. They organize themselves into states of exquisite precision, with properties that are exact, universal, reproducible. You too have the capacity for order, for structure, for creating patterns in your life. Not rigid, inflexible patterns, but organic, living patterns that emerge naturally from your choices, your habits, your values. And right now, as you rest, as you let go, your body is creating order. It's repairing cells, consolidating memories, restoring balance. It's finding its way to the ground state, the most efficient, most harmonious configuration. Let's talk about Bose-Einstein condensates, a state of matter that occurs when you cool a gas of bosons, a type of particle, to temperatures very close to absolute zero. At these ultra-cold temperatures, the particles lose their individual identities and merge into a single collective quantum state. They all occupy the same quantum state, moving together, behaving as one. This is matter, behaving as a wave, a coherent, unified wave, rather than a collection of individual particles. It's one of the most direct demonstrations of quantum mechanics on a macroscopic scale, something you can almost see, almost touch, and it's a reminder that separation, individuality, is not absolute. Under the right conditions, things can merge, unify, become one. The boundaries between self and other, between inside and outside, are not as solid as they seem. As you drift deeper into sleep, perhaps you're experiencing something similar. Perhaps the boundaries of yourself are softening, expanding, dissolving. Perhaps you are merging with the quiet darkness, with the space around you, with the universe itself. You are not a separate, isolated thing. You are part of the whole, connected, entangled, one with everything. Let's talk about the concept of quantum erasure again, but from a different angle. The key insight is that information is physical. When you measure which path a particle takes, that information is stored somewhere, in a detector, in a piece of equipment, in the environment. And as long as that information exists, even if no one has looked at it yet, the interference pattern is destroyed. But if you erase that information, if you make it impossible for anyone to know which path the particle took, the interference pattern comes back. It's not about consciousness or observation in a mystical sense. It's about information, about what's physically possible to know. This suggests that the quantum world is deeply connected to the concept of information, that reality at its most fundamental level might be informational, not material. Perhaps matter and energy are just ways that information manifests, just patterns in a deeper, more abstract substrate. And if that's true, then your thoughts, your experiences, your awareness are not just epiphenomena, not just side effects of physical processes. They are part of the fundamental fabric of reality, part of the information that makes up the universe. You matter. Your experiences matter. Your awareness is not an accident or a byproduct. It is part of the story, part of the process, part of what the universe is doing. Let's drift into the idea of quantum contextuality. This is the property that the result of a measurement depends not just on the quantum state being measured, but on what other measurements are being made at the same time. You can't assign definite values to all properties of a quantum system independently. The values depend on the context, on the full set of measurements being performed. This is deeply strange. It suggests that reality is not made of independent facts that exist separately from each other. Instead, reality is contextual, relational, dependent on the whole situation, not just on isolated parts. And perhaps this is true more broadly. Perhaps the meaning of anything, the truth of any statement, the value of any experience, depends on context, on relationship, on how it fits into the larger whole. Nothing exists in isolation. Everything is connected to everything else, and the properties of things emerge from their relationships, not from some intrinsic, independent essence. Let's talk about the concept of quantum annealing again, but thinking about it as a metaphor for problem solving. When you face a difficult problem, you might start by exploring many different approaches, many different possibilities. This is like the high energy state, where you're trying everything, not yet committed to any one path. But over time, as you learn more, as you test different approaches, you gradually narrow down your options. You eliminate paths that don't work. You focus on the most promising directions. You cool down, anneal, settle into the solution. And sometimes, the best solution is not the one you expected. Sometimes it emerges naturally, organically, from the process of exploration and elimination. You don't force it, you don't impose it, you simply allow it to reveal itself. This is what's happening as you fall asleep. You're not forcing it, you're not trying to make it happen. You're simply allowing your system to cool, to settle, to find its way naturally to the ground state of rest. Let's talk about the holographic principle, an idea from theoretical physics that suggests the information in a volume of space can be encoded on the boundary of that space, like a hologram. The three-dimensional world we experience might actually be a projection from a two-dimensional surface, with all the information contained on that surface. This is a speculative idea, but it has deep connections to quantum mechanics, to gravity, to the fundamental structure of space and time. It suggests that reality is not what it seems, that the dimensions we perceive might not be fundamental, that the universe is stranger and more subtle than we can easily imagine. And perhaps, in your own experience, something similar is true. Perhaps the richness of your inner life, the complexity of your thoughts and feelings, is encoded in a simpler, more fundamental substrate. Perhaps consciousness is a kind of hologram, a projection from a deeper level of reality. You don't need to understand how this works. You only need to let it remind you that you are a mystery, that consciousness is a mystery, that the experience of being you is something that cannot be fully explained or reduced or captured in any simple description. You are more than the sum of your parts. You are a pattern, an emergence, a hologram projected from the quantum fields, a unique and irreplaceable expression of the universe's infinite creativity. Let's slow down. Let your breathing be soft and easy. Let your body be completely at rest. Let your mind drift gently, like a leaf floating on a stream. Now, let's think about the future. Where is quantum physics going? What mysteries remain to be solved? There are many questions still unanswered, many frontiers still unexplored. How do we reconcile quantum mechanics with gravity? What happens inside a black hole? What is dark matter? What is dark energy? Is there a deeper theory underlying quantum mechanics, or is this the end of the road? We don't know, and that's okay. That's part of the beauty of science, the ongoing quest, the endless curiosity, the willingness to say, I don't know, and then keep searching, keep questioning, keep exploring. And in your own life, there are mysteries too, questions without answers, uncertainties that cannot be resolved, futures that have not yet unfolded, and that's okay. You don't need to have everything figured out. You don't need to know what's coming. You only need to be present, to be open, to be willing to take the next step, even when you can't see the whole path. The universe is vast, and you are a small part of it. But you are also, in a sense, the universe experiencing itself, aware of itself, wondering about itself. You are the cosmos looking back at the cosmos, a point of view, a perspective, a way that the universe has become conscious. And that's extraordinary, that's miraculous. That's something to be grateful for, even in the midst of uncertainty, even when you don't understand, even when things are hard. Let's talk about quantum biology, the study of quantum effects in living systems. For a long time, people assumed that quantum mechanics was irrelevant to biology, that the warm, wet, noisy environment of living cells would cause decoherence too quickly for quantum effects to matter. But recent research has shown that life uses quantum mechanics in surprising ways. Photosynthesis, the process by which plants convert light into energy, involves quantum coherence. Birds might use quantum entanglement to navigate using the Earth's magnetic field. Enzymes use quantum tunneling to catalyze reactions. Life is not just classical, it's quantum. You are a quantum being, not in some vague mystical sense, but in a precise physical sense. The processes that keep you alive, that allow you to move and think and feel, are governed by quantum mechanics. And perhaps this means that you are more connected to the universe, more deeply embedded in its fabric than you ever imagined. You are not separate from nature. You are nature expressing itself in a unique and beautiful way. Let's talk about the measurement problem one more time, because it's at the heart of all the strangeness. The measurement problem is simply this. Why does measurement cause the wave function to collapse? What counts as a measurement? When exactly does the collapse happen? There are many interpretations, many proposed answers. The Copenhagen interpretation says measurement is a primitive concept, not to be further explained. The many worlds interpretation says there is no collapse, only branching. The pilot wave interpretation says particles always have definite positions, guided by a quantum wave. The objective collapse theories say collapse happens spontaneously, triggered by some physical process. No one knows which interpretation is correct. No one knows if any of them are correct. The measurement problem remains unsolved, a deep mystery at the heart of our most successful scientific theory. And perhaps that's fitting. Perhaps the universe is allowed to have mysteries. Perhaps not everything needs to be explained. Perhaps there is room for wonder, for awe, for a kind of humble not knowing that is itself a form of wisdom. You don't need to solve the measurement problem tonight. You don't need to understand everything. You only need to rest, to let go, to trust that the universe will continue to unfold, whether you understand it or not. Let's think about the concept of quantum discord, a measure of quantumness in correlations between systems, even when they're not entangled in the strict sense. It turns out that quantum correlations are more general than entanglement, that there are ways for systems to be quantum correlated without being entangled. This is a subtle distinction, but it's important. It tells us that the quantum world is richer, more nuanced than we initially thought. There are more ways for things to be connected, more ways for information to be shared, more ways for systems to influence each other. And perhaps the same is true in your relationships, in your connections with others. Perhaps there are subtle influences, quiet resonances, ways that you affect each other that are hard to name or describe, but are nonetheless real. You are connected to everyone you've ever met, everyone you've ever loved, everyone you've ever shared a moment with. Those connections are real, even when you're apart, even when you're not consciously thinking about them. Let's drift into the idea of the quantum to classical transition, the question of how the quantum world, with all its strangeness and superpositions and entanglements, gives rise to the classical world of definite states and predictable behavior. This is still an active area of research, but the key concept is decoherence. As systems interact with their environments, they become entangled with many particles, and the quantum information spreads out, becomes inaccessible, effectively lost. The quantum world doesn't disappear, it's still there, underlying everything, but it becomes hidden, masked by the noise of countless interactions, leaving only the classical behavior that we observe in everyday life. And perhaps something similar happens in your own mind. You have depths, layers, unconscious processes, quantum potentials that you're not aware of. But your conscious experience is like the classical limit, the surface layer that emerges from the deeper quantum substrate. You are more than you know. You contain multitudes. You have depths that you cannot access directly, but that nonetheless shape who you are, how you feel, what you choose. Let's think about quantum computing one more time. The promise of quantum computing is that it can solve certain problems exponentially faster than classical computers. But quantum computers are fragile, sensitive, hard to build and maintain. They require ultra-cold temperatures, careful isolation, constant error correction. And yet, despite all the challenges, progress is being made. Quantum computers exist, they're getting better. They're starting to solve real problems, to demonstrate quantum advantage over classical machines. This is a reminder that difficult things are possible, that challenges can be overcome, that persistence, creativity, and hard work can lead to breakthroughs. And perhaps the same is true for your own challenges, your own difficulties. Perhaps they seem overwhelming right now, impossible to solve, but with time, with patience, with the right approach, you can make progress, you can find solutions, you can overcome. Let's talk about the concept of quantum scars, patterns that persist in the energy eigenstates of certain quantum systems, remnants of classical periodic orbits. This is a beautiful example of how classical and quantum physics are not entirely separate. How echoes of classical behavior can persist even in the fully quantum regime. The universe is not divided into separate realms. Everything is connected, everything flows into everything else, and the boundaries between different descriptions, different theories, different ways of understanding are soft and permeable. You too carry scars, memories, patterns from your past that persist even as you change and grow, and that's okay. Those scars are part of you. They tell your story, they shape who you are. You are not trying to erase your past, you're integrating it, learning from it, allowing it to become part of a larger, more complete version of yourself. Let's slow down one last time. Let your body be completely still. Let your breathing be barely perceptible. Let your mind be like a calm, clear lake, reflecting the sky. You have drifted through the strange world of quantum physics, through ideas that are as bewildering as they are real. You've encountered superposition and entanglement, tunneling and uncertainty, wave-particle duality, and the measurement problem. You've seen how the universe at its smallest scale is fluid, open, creative, full of possibilities. And perhaps, as you've listened, you've felt some of that openness, some of that possibility in your own experience. Perhaps the boundaries of yourself have softened. Perhaps your sense of separation from the world has eased. Perhaps you've touched, however briefly, that deeper state of connection, of unity, of quantum wholeness. You are part of the universe. You are made of the same particles, governed by the same laws, woven into the same fabric of existence. You are not separate from the stars, from the atoms, from the quantum fields that fill all of space. You are a temporary concentration of energy and information, a beautiful, unique pattern that has arisen from the quantum foam and will one day return to it. But for now, you are here, you are alive, you are aware, and that is enough. As you drift now into sleep, let yourself go completely. Let your thoughts dissolve like mist. Let your body sink into the deepest rest. You have journeyed far tonight, through the strange landscapes of the quantum world, and now it is time to rest. The universe holds you. The quantum fields cradle you. The great, mysterious, beautiful cosmos from which you came, and to which you will return, surrounds you with gentleness and care. You are safe, you are loved, you are part of something infinitely vast and infinitely tender. Sleep now, let go, drift into the quiet darkness, and know that when you wake, you will still be part of this quantum dance, this strange and wondrous unfolding, this miracle of existence that continues, moment by moment, breath by breath, forever creating itself anew. Rest well, dear traveller. The universe is dreaming through you, and the dream is beautiful.